We're going to start off with Charlie Luxton, who is going to be here, and he's going to be discussing the wider issues around old windows and climate change. And he is also going to explain a bit more about his journey to develop a new secondary glazing product, which isn't on the market yet, but he's going to explain all about that. So that's going to be quite interesting.
Hello, everyone. Hello. Can you hear me? Yes, you got me. Right, brilliant. So I don't have very long, and I'm afraid at the end of this I have to run away. And when I finish talking, which is really annoying, so I won't be able to answer questions because I'm supposed to be at the theatre at 6:30 in London. So I might get divorced as it stands, but if I stay, I will definitely be divorced. So I'm going to have to leg it, I'm afraid. But just quickly, I think it's really worth understanding and just starting with some bad news. I don't know how much bad news you've sort of discussed overall in the last couple of days, which, you know, being here today, it's been a fantastic event, is the 10 warmest years since 1850 have been the last 10 years. The 12 months to February 2024, we exceeded 1.5 degrees pre-industrial levels temperature. 1.5 degrees temperature rise since pre-industrial levels. We did that for 12 months. Now, there's an El Nino event in there, but the idea of significant human influence climate change is very, very real. Now, there was a time when you had to sort of persuade people that was a reality. I think people kind of get it because we've also had the wettest 18 months since records began. So things are clearly changing. But it's not just the climate that's changing, it's also the world of resources. In my lifetime, the average animal population has dropped by over 60%. Yeah? So every species has had an average loss of 60% in my lifetime. So we, as people in the built environment, have a huge responsibility for that because, as you can see, we produce, roughly between 35 and 40% of all CO2 comes from our buildings, okay? So you people in this room, I know you're working with older buildings, so there's some benefits there, but you guys are right in the firing line of being part of the solution to this challenge. And it's quite a hard challenge because we have some very sort of fundamental algorithm problems to dealing with this because we've evolved to run after things and hunter-gather things and hang out in groups of 200 and deal in fairness. We're incredibly good at those things. What we're a bit crap at is assigning value to large future challenges, right? We're much better at assigning value to small immediate challenges. But something like climate change, as I'm sure you've all felt personally, is really hard to conceptualize and deal with. We're also really bad with understanding statistical long-term trends. They just don't come naturally to the way that our brains work. Things like the sunk cost fallacy. So if you've invested a load of money in something and it's not working, you'll just keep investing because I've already put this money in, but actually we should just stop and change direction. And finally, and perhaps the one that is arguably been the most issue around climate change and why, and I think something the conservation area has slightly suffered from is slightly bystander effect, okay? So you're on a street and someone trips over, somebody trips over, an old person trips over, and you stand around going, someone's gonna help them. Somebody's definitely gonna help them. Somebody's going to help, and I think we've all been going, someone's going to solve climate change. You know, it's not really down to us because of whatever internal dialogue, their old buildings, all these internal dialogues. It's not, but actually it's up to all of us. We all need to really get involved and start putting the shoulder to the wheel. And just one last kind of, oh my gosh, fact that over the next 50 years, it is predicted that we will add 230 billion square meters of new construction. That's the equivalent of Paris every week. So that's the thing. We also have a massive challenge, as you've seen. About 35% comes from building stock, and that is supposed to be zero by 2045, 2040, because as you'll see, residential, non-residential buildings go to zero in the transition to climate change. And that includes the 17% of housing, which is roughly pre-1919. So I think there has been a slight kind of idea that these buildings are old and therefore they're not really part of the problem. And I don't think that, and I'm being slightly provocative, by the way, okay? I've been asked to do that. So, they're not really part of the problem. And I think, I don't think that's a position that can be held for much longer. And I'm not certainly saying the people in this room, because you're here, you're probably self-selectingly not in that position. The other thing is that construction is the biggest waste producer on the planet. So, it's incredibly wasteful. And within that are both, is both large-scale construction, but also just tearing out and throwing away perfectly good windows, as we've heard about, is, and glass, as we know, is incredibly energy intensive. So there has to be a change of mindset around what we trash and what we reuse and how we reuse. And what's really interesting about this whole debate, and I think really going to come to the fore in terms of the whole carbon emissions and architecture sort of conversation, is life cycle carbon modeling. So I don't know if any of you have done much life cycle carbon modeling. It's a very interesting process. Certainly you do it on new buildings, where you basically assign every material in the building a carbon allowance, and you understand its replacement rate, and you understand its energy generation capacity and its energy losing capacity, and you create very complex models that give you a figure. To be honest with you, those figures are slightly not as accurate as they should be yet, because it's very new industry, but it is starting to really change the way in which this conversation is happening. And one of the big things that you start to understand is that in a low energy building, building a new building, building the thing is probably 60% of its carbon during its life cycle, during its 60-year life cycle. So therefore, inherently, an old building is kind of ahead of the game on that position. But what you find with older buildings, obviously, is that these operational emissions are significantly higher, and there are still these replacement and maintenance issues that come to pass. And you see big lumps like this here, which will be the replacement of the windows and of the PV systems and of roof membranes and everything. And where I think this is really interesting is it starts to change the conversations you have with clients about investment, right? Because those conversations about failure rates is really unusual to have anyone in construction talking about failure rates. Do you know what I mean? No one gives a monkeys. It's like, get it done, get it built, move on. So what looks like a bloody good deal, like a single ply membrane, for example, shorter lifespan, on day one, after 20 years is not a great decision. After 6 years is a really dumb decision, because you've put 3 bloody roofs on, and one felt or hot melt, traditional hot melt roof will still be there. So how do we justify this additional expense into architecture when, you can't justify payback? It's this. It is life cycle carbon and therefore cost analysis that is going to give us the tools to start challenging short-termism and poor assumptions about architecture. So it's complex. It's quite a bar to get into it. Quite how it's going to roll into historic buildings is interesting, but something to get involved in. And one of the things that is interesting about that is that, so clearly what it means is that the most sustainable buildings one exist. And the American Institute of Architecture have worked out that it doesn't matter how low energy a replacement building is, pretty much, that if you take a building and it's like a 50%, it's a half as much energy consumption, it still takes about 50 years to pay back the carbon investment of knocking it down and rebuilding it. And the point is, we do not have 50 years. We have until about 2050 before things get critical. Because if we hit sort of 3 degrees in 2060, you're looking at about 12% of the human population having to be relocated or regularly flooding. And New York, Amsterdam, Shanghai, Rio de Janeiro, Amsterdam, goes on and on and on, will be pretty much underwater or certainly behind incredibly expensive carbon barriers. So, there's some good things going on for the sustainability industry, because it is the most sustainable building, but you can't be complacent. And one of the things that's come, interestingly, I find a lot from what we do, is that things that start in the commercial sector sort of start to roll down into the residential sector, into the wider society. And one of the things that a lot of people are saying is that, like, big finance has got climate change. They understand what is going on and they're investing in it. And we're doing work for an ethical investment company. But when you talk to them, they never even mention the word ethical investment. They just say, we invest in the stock market. If we stay in companies for the long term, we get the miracle of compound interest, and we make our clients lots of money. And I started having a long conversation with them. After 20 minutes, I'm like, you haven't said the word ethical. They're like, we don't need to say the word ethical. Because if you invest in a company that is actually fit for purpose in a changing economy and a changing climate, they're going to be the ones that last for a long time. That's who invest in, that's how we make money, right? So finance and big business gets this, okay? What we're starting to see is finance and big business, when they come to rent new buildings, are really starting to look at the buildings they rent. And they are starting to, talking to people at Savills, they're starting to have less and less success renting some of the older buildings in central Oxford, for example, because of the increased carbon emissions with the heating, right? And that is only going to grow because your scope 1 and 2 carbon is going to land somewhere on your book. So there is definitely a challenge coming down the path from that perspective. What's interesting is even some guys up in London who I know, he's done some really good, like Barker's department store, and he's got a very wealthy client who owns all of these amazing iconic buildings, and he's done 5 minutes. Oh, God. Anyway, this is a great story. Empire State Building, 102-story, 1930. Needed to do something about improving the thermal performance. So they made a factory on the 5th floor, took all the windows down, changed all the glazing, and put them all back up. And they saved $5.5 million, and they saved 100,000 tons over 15 years. So we need that kind of big thinking. Would you even be able to touch that? I don't know in this country, but the fact that they were allowed to make a factory on the 4th floor is a fantastic thing. So I understand windows have got a critical role to play in architecture. I own this little cottage. It's listed for reasons slightly escape me, but it's nice. And we did a deep retrofit to it, internal wood wall fiber, insulation on the floor, under the thatch. And we managed to replace the windows because a lot of them had already been replaced to aluminium. And they'd done their own secondary glazing where they'd got a rubber tube and pushed it against a sheet of glass, and then pushed another sheet of glass against it, and then tapped a little thing, which was, and actually the conservation officer, who unfortunately is retired, was very reasonable and brilliant to work with Rose at Cherwell, and we managed to change all the windows, and they're stick-on glazing bars at the front. But there were 2 windows on the back that were more interesting and older, and I didn't want to replace. The one on the bottom right, you can see, I think it's like an old sash. We think it's an old sash, and the one at the top. So the one on the right down at the old sash, we did slim light glazing, slim light, 3 mil slim stuff. And actually, we lived with that for about a year and had real condensation issues around the glazing bars. And I thought, that's not quite work. So then, but that's it there, sort of remade and repaired and so on. And then there was this window upstairs, which is a lovely, lovely kind of steel metal interstitial bar and lovely glass, and I didn't want to do it. So I got a double glazed unit. I didn't tell the conservationists. I got a double glazed unit with an outer step on the outside and screwed it to the window. And that worked pretty well. A little bit of condensation, so it worked pretty well. But it made me go, right, there's a problem here. We're looking at all these things, and all these windows are being taken out. So I talked to my brother, who's at the front there, who's going to stay and answer questions afterwards. He's an engineering wizard. And I said, there's a problem that needs solving. And I had been to Finland, where they do triple glazing, have done for years. What they have is a single glazed outer pane and a double DGU on the inside. And the reason they have the DGU on the inside the single glazed unit is it makes the double glazed unit last significantly longer if you can mediate its temperature by having the single glazed unit on the outside. So you massively extend life expectancy if there's a double glazed unit is slightly protected from the outside. You don't get as big temperature variation over the front. So we came up with an idea for sticking a window inside a hole and blowing it up to hold itself in place.
So here we have a perfectly good condition single glazed window, and looked after it could carry on for many, many years. Now, in order to transform it into an A-rated equivalent window, we have panu. Comes from tire in French because it has a hydraulic seal around the outside of the window. So we would come to site, measure the reveal, the opening that the existing window sits into, and then have a panu unit made specifically for that opening. So what it consists of is an accumulator along the bottom, which has some fluid in it, and a seal around the outside. You pump air in through this cylinder, it pushes a piston which forces the fluid around the seal and fills the opening, holding the window in and creating a completely draft-free A-rated window. The other important thing to note is that it is a double glazed unit. So there are 2 sheets of toughened glass, low E on one of them, and argon filled in the middle to make it have a U value of about 1.1, 1.2, depending on the size and shape of the final unit. So you pop the window in, goes in nice and easily, and you put on a pump. Hold it in place, hold it upright, and just pump. That is now pushing this piston down the chamber, forcing the fluid out into the seal, which is slowly expanding, gripping onto the opening, stopping any air leakage, and holding itself in. So that is now securely fitted. And this back painted glass section here, this can be coloured to match your existing window frames. And there you have a draft-free, noise-reduced, thermally high-performing window without any mess, hassle, or redecoration. And crucially, because the seal is just pushing out onto the reveals of the window to not only hold itself in and give you the air tightness, it's not actually fixed to the window. It makes it perfect for listed and historic buildings.
So that's the idea. It then, on its own, it's got a U value of just over 1. We suspect that in conjunction with the windows, it would be lower than that. And critically, what we're looking at is on that unit is 2mm glass. So there is no manufacturers of 2mm glass in this country, but there is an Austrian company who have developed 2mm float glass for the use in PV panels because it has a much higher light transmission. So you're reducing the amount of carbon because you've got half as much glass. It's much lighter to move. You can actually put much more of it on a lorry or in a van to move it around. And it's much easier to put in and out of the windows. Now, unfortunately, as I said, we were getting these made in Austria, and we've been then mucking around with 4mm glass for other units. So this is an installation in my brother's old flat, which has been in place for about 8 years. And that's the window above. It's this bay. Those are uninsulated windows. You can see the windows are so cold. This is a thermal imaging camera. You can't even see them because they're actually more insulated than the walls of the bay. And there's a cat, which is great. There's a cat in front of the window. Look how, there's it walking on this ledge above them. So that's good. This is my parents' house. We put one in there. We mucked about with it. And then they begged us for the rest of them because they were spending so long hoovering the windows, like somebody mentioned earlier, all those problems, and all the frames are rotting out. So now you can see this window here is completely off square, and they just pop in and it blows up. And they've just hassled us to get the rest finished for years, which we've finally done. And that's into a large set of bays. That central bit just pushes in with little bits of expanding foam top and bottom, and then it all holds itself in place. And it's quite neat. And this doesn't have to be metal. My dad likes Bang & Olufsen's, so we did that from the 70s for him. And we got a patent which took 6 years because that whole idea of the air activating the fluid moving around the frame. Because when we did it first, we were had this idea, and we got a piece of wood and we put a tire around it, like an inner tube, pumped it up, and it stuck in, and we were like, that's brilliant. Literally went to the pub, had a couple of pints, came back, and it had fallen, or the next morning it had fallen out because air goes through seals. And then we were like, oh my God, we can't get the air to come out of the seal, so we had to invent the kind of hydraulic integration. The one thing Richard did find, which was sodium hexafluorochloride or something, which is sodium sulfur hexa whatever. And he's like, I've solved it, it won't come out. And then we found out 1 kilogram of that gas is worth 32 tons of CO2. It's like, oh, bugger, right, back to the drawing board. So it doesn't solve everything. And as I think it's been put really nicely throughout all this thing, it's like lots of different solutions for every different window. You have to take them out in summer, like a lot of the double glazing things, stick them under a bed. My parents take one out in the winter and the summer and put them back in. That works really well. But they're amazing in terms of noise and all the other things we've heard about today. And anything else? No, I think we're out of time. But basically, what we're looking for is we've had them in my parents' house, we've had them in his house, and in other houses. We're now looking for small production runs. It's not on the market. We're looking for small, sympathetic clients who might want 8 or 10 windows that we can work with to refine the measuring and manufacture process to sort of get it out there because we think it's pretty cool. Anyway, that was a rant. Thank you very much.
Thanks very much, Charlie. That was great.